Hello and welcome to today's session. In this lesson, we will focus on Learning Outcome 3, Designing a Database System. Are you ready to dive into the fascinating world of database design? Today, we will explore the key stages involved in creating a robust and efficient database system. From planning and structuring data to ensuring integrity, security, and performance, each step plays a critical role in building a system that works seamlessly. By the end of this session, you'll understand how thoughtful design can make databases reliable, scalable, and secure. Let's get started on this journey to mastering database design. The first step is understanding what the database needs to achieve. This involves gathering data requirements from end users and business processes. Interviews, surveys, and workshops are crucial here. The outcome is a detailed document outlining data needs and constraints. This foundation ensures the database supports all necessary operations. Next, we create a high-level data model. This model describes main entities, attributes, and relationships. Entity relationship diagrams are used to visualize these components. The goal is to capture the database's overall structure. This step is crucial before moving to implementation specifics. Logical design translates the conceptual model into a logical schema. It defines tables, columns, data types, and keys. Normalization is applied to reduce redundancy. This ensures integrity and prepares the design for a specific DBMS. The logical schema is the blueprint for the next phase. Physical design focuses on how data will be stored and accessed. It involves choosing storage structures and indexing strategies. Optimization for performance is key. The physical schema details how data is stored on media. This step bridges design and actual implementation. Implementation is where the database becomes real. Using a DBMS, tables and relationships are created. Constraints are enforced, and initial data is populated. This results in a functional database. It's now ready for testing and validation. Testing ensures the database meets all requirements. Unit and integration tests are conducted. Performance tests validate efficiency under load. Data integrity and security are checked. A validated database is ready for deployment. Deployment moves the database to a production environment. Monitoring and maintenance are ongoing tasks. Regular backups and updates ensure continued performance. This stage ensures the database remains robust. It's now operational and maintained for optimal use. Consider a student enrollment system as an example. Key entities include students, courses, and enrollments. Attributes and relationships are defined for each. This practical application illustrates database design in action. It shows how theory translates into a working system. Normalization reduces data redundancy and improves integrity. It involves several forms, each with specific rules. The goal is to ensure all attributes depend on the primary key. This process is crucial for a well-structured database. Achieving third normal form is often the target. Designing a library management system involves several steps. Logical design defines entities like books, members, and loans. Physical design implements these using a DBMS. Data flow and attributes are documented. This ensures a comprehensive and efficient database. Documentation tools like ERD and DFD are essential. They provide visual and detailed representations of the database. A data dictionary details structure and attributes. These tools ensure clarity and understanding. They are vital for developers and stakeholders alike. Validation and verification enhance database integrity. Validation checks data accuracy and rules compliance. Verification ensures design and implementation correctness. Both processes are essential for a reliable database. They ensure data is accurate and the system functions correctly. Performance benchmarks assess database efficiency. Key metrics include query response and transaction throughput. Resource utilization and scalability are also measured. These benchmarks identify improvement areas. They ensure the database operates optimally. Opportunities for improvement include better validation. Implementing automated tools enhances schema verification. Regular index monitoring optimizes query performance. Constraints and triggers enforce data integrity. These enhancements ensure a robust database system. Correct. Presenting the design to the client involves clear communication. The ERD and DFD illustrate the system structure. A data dictionary provides detailed insights. Normalization ensures efficiency and integrity. This presentation assures the client of a well-designed database. This is the conclusion of the video. Designing a database system is a comprehensive process. From requirements to deployment, each stage is critical. By following these steps, a robust database is achieved. This ensures efficiency, reliability, and security. The database meets business needs and supports operations effectively. Questions? Reach out via WhatsApp at 074843616888. Our team is always happy to help. Thank you for your attention, and see you at the next session.